Welcome back, friends. In today's class we'll talk about impulse. Now if I look into the definition of impulse, it is same as writing the change in momentum. Change in momentum, which is equal to delta P. And if I write down the formula for delta P, which is equal to m v final minus v initial, that is the change in momentum. And this is also equal to impulse. Impulse has another definition, that is area under the force time graph. And to solve the mathematical problems, we will use both these formulas. Now why I called it as area under the force time graphs, we'll see. So first of all, I'll write down the formula delta P, which is equal to m v final minus v initial. Now let's say if I divide this by delta t and this with delta t also, what's gonna happen is if I look into this portion, this becomes change in velocity with respect to time, which is equal to mass times acceleration. So delta P divided by delta T is equal to F net average in this case. And then delta P, I'll cross multiply both sides with delta T, multiply this with delta T. So this becomes delta P equal to F net average multiplied by delta T. And delta P is also equal to impulse, we know that. So thus impulse can be found out by two ways. One is by changing the momentum, another by taking the area under the force time graph. Now this is one of the formula. You can say that, oh hang on, you wrote the formula as F net average times delta T. Now all the time you won't be given the net force, so that's why it is better to remember it as area under the graph. So I'll show you two graphs, force time graph, both of them. This is force, this is time. In here force, time. If the graph looks something like this, a horizontal line, it means what? The net force is not changing, it's remaining the same, constant throughout the time, given amount of time. So I can use this direct formula. But if the graph looks like this, which is more of a real life situation where the force increases for a given time and then reduces over a given amount of time. So in this one, the average force is F net average is not given to me, that is not given, whereas I've been provided with the peak force. So it's always better to remember the definition as area under the graph. So area under this graph will be the area of the triangle for this case, this type of scenario. So impulse will be equal to half times F peak times delta T, that is impulse. So the formula, if you might have seen, formula keeps on changing. For this one it was F net average times delta T, impulse. So basically it depends upon what's given to us. Now you're gonna ask me why impulse is important, why we are studying the impulse, because we've already studied the change in momentum delta P, which is equal to mv final minus v initial, and you are saying that is equal to impulse. Then why we need to study all these things? So to answer that question, I'll tell you that if I talk about only this formula scientifically is not that much of significance. So impulse is the most important thing, and the impulse with respect to force times delta T, that is that has more significance in real life problems. I'll show you why. So let's say if I take an example of a car, and this car is moving at 100 kilometers per hour, and it sees an obstruction in front of it. All right, and that obstruction is quite far away, and this car, before reaching to the obstruction, comes to the rest and stops, and the velocity is at this location, the velocity becomes 0, and then the f net, or shall I say the momentum will also be equal to 0. Here it has certain momentum p initial, and here final momentum is equal to 0. So when you apply the brakes, so that's a very simple condition where nothing has happened. Now, why impulse is important when we talk about the car crashes? So how much momentum is changing with respect to time? How much momentum is changing in a given amount of time? That will provide us the force, and that is the important thing. So if I write it, if I go back into the previous formula, delta p upon delta t, which came out, if I go back into the equations which I wrote here, so delta p divided by delta t, this was equal to what? Delta p upon delta t, this is equal to force. So change of momentum with respect to the time, that provides us the force felt. In this previous example, where the driver was driving at 100 kilometers per hour, and then he slowed down his car and the velocity became 0. So this momentum, change in momentum, was over a huge amount of time. So let's say the change in momentum was let's say 2000 kg meters per second, but this car came to the halt over 10 seconds. Okay, so I divided these two. So the force felt in every second, average force felt by the driver in every second, will be 200 newtons only. Now imagine if this car crashes, this was equal to force average. So if this is a car which is moving at 100 kilometers per hour, and there is a obstruction in front, and this car crashes into this obstruction, what's gonna happen? All of a sudden the car was moving with 100 kilometers per hour and came to the rest. So let's say a whole of this process happened over a period of, let's say, delta time t equal to 0.5 seconds, in a split of a second. So the force felt, so again I'm gonna say the change in momentum was equal to 2000, let me sharpen up the pencil, 2000 kg meters per second. And then if that was the change in momentum, and that change in momentum occurred over a 0.5 seconds, so 2000 divided by 0.5 equal to force felt average, that will come out to be 4000 newtons force average. Now imagine, in the first case the driver felt a force of 200 newton, and in the second case the driver felt, when the car crashed, the driver felt a force of 4000 newtons. So obviously this is more dangerous, isn't it? So while driving the car, while manufacturing the car, shall I say, the main thing we need to make sure that the car should come to rest over a large amount of time. So we wanted to make sure that, because the change in momentum will remain the constant, this value, whatever the mass of the car is moving with 100 meters per sec, 100 kilometers per hour, and it comes to the rest. What we want to make sure is that that time period from 100 kilometers per hour to 0 meters per second, we wanted to increase the time span for this, so that even in the case of an accident, the driver can survive and he will feel the less force. And thus, nowadays when the cars are designed, they are designed in such a way that the front portion of the car crashes. So if the front portion of the car will crash, so slowly this car will keep on moving in the forward direction, and that will increase the time period even by a split second, but that will be a big help. So think about this: if the car came to rest in 0.5 second, and but you increased it by only 0.5 seconds by crashing, by making sure that the front portion crashes down and it is not 100% rigid, so you increases by to 1 second, so the force felt will be 2000 divided by 1. So it means the driver will feel half the force by only increasing it by half a second. So that's where the impulse comes into picture. So hopefully you were able to understand why the impulse is so important in real life examples. So again, I will write down the formula for impulse, that is equal to area under force time graph, or it can be said that change in momentum, that is impulse. Now based on this formula, I'll try to take an example and try to simplify that example. So let me consider this example. If I take the example number 7, so I'm gonna take this example number 7. So from the graph given below, what is the magnitude of the impulse provided to a 48-gram tennis ball that is served due to south? Now if I see, it's asking me about finding out the impulse. So as we've already said, impulse is what? Area under the graph. And area under the graph, this is a triangular graph. So if I draw it on my canvas, it will look like this. And then this is time, and this is force felt. And what other piece of information is given to me? Maximum force felt is 900, and the time starts from 0.5 seconds. This is really important. This is not starting from 0 seconds, neither it's starting from 1 second. It's starting from 0.5 seconds and stopping at 5.5 seconds. So it will be 0.5 to 5.5 seconds. So this time span is equal to 5. Let me check the units also. So the units are in millisecond, guys. So make sure you pay attention to the time also. So it will be, time given to us is 5 milliseconds. 1 second equal to 1000 milliseconds. Or we can also write 1 millisecond is equal to 1 time 10 raised to the power minus 3 seconds. Whatever way you wanted to remember it, you can do that. And the peak force is 900 newtons. That's what's given to me. And I wanted to find the impulse for this question. So impulse value will be equal to, impulse is equal to half times base times height, because that's the triangle. Area of a triangle is what? Half times, this is base, and this becomes height. Half times base times height is the area of the triangle. So if I plug in the values in this, so this will be half times 900 times 5 times 10 raised to power minus 3. And then if I do the calculations, it will come out to be 450. I can reduce this to 450 times 5 times 10 to the negative 3, and then 450 I can do the complete in one step, times it by 5, that is 2.25 Newton second or kg meters per second. Now you're gonna ask me the question, hang on, we were writing these units by now, all of a sudden why you are writing the Newton second? So the answer to that is Newton second is same as writing kg meters per second. If you can recall the formula for impulse, there was the two formulas which we did. One was the F net average times delta t, which is equal to change in momentum. So these are the units for change in momentum. Units of net average forces, this is Newton, the time is seconds, which is equal to delta p. So both are one and the same thing. Or what you can do is, another way of looking at this is, if I look at here, so F is the units of force is newtons, and if I elaborate onto this units, force is also equal to mass times acceleration, and mass times acceleration units are meters per second square, and that is the units of force. And what we want to do is force multiply by time. So meters, this is, I should have wrote here as kgs. So this is kgs. So here it will be kg meters per second square times by second, and this second cancels out. It will be kg meters per second. So both mean one and the same thing. So coming back to the question, so we figured out the impulse value. So impulse value is 2.25 Newton second. Then we'll try to find out the answer to the part B of this question. What is the velocity of the ball when the racket and the ball separates? So part B, so initial velocity, you will agree when the ball was in hand, you can put it this way, the initial velocity is equal to 0, and we wanted to find the final velocity. That's what we wanted to find out. Now as soon as I see the velocity, the second formula will come to my mind, because I wanted to find out the velocity final. The formula for the impulse, second formula is mass times v final minus v initial, and then I'm going to use this formula, and mass of the ball given to me in this question is 48 grams. So 48 grams means how many kgs? That's what I wanted to find out. So 1 kg equal to 1000 grams. So 48 grams will be equal to 0.048 kgs. We can also write it 1 gram is equal to 10 to the negative 3 kgs, and I can write it as 48 grams equal to 48 times 10 to the negative 3, or 0.048 kgs. Whatever you like, you can convert it by that method. In the end it will come out to be this value. So 0.048 multiply by v final, that's what we wanted to find out. Initial value is 0, impulse value is given to me 2.25, and then this will come out to be 0.048, v final 2.25, and then dividing both sides by 0.048, and this side also 0.048, it will come out to be 2.25 divided by 0.048, that comes out to be 46.8. 46 point, well, 875 V final, we can round it to 48.9 meters per second also. So hopefully you were able to learn something about the impulse and what is the practical implementation of impulse, why it is important to study the impulse. And I will see you guys in the next class with 1D collisions. See you now. Bye.